Today I'm going to show you how you can use RabbitMQ as a message broker, so your services can use it to communicate without calling each other directly. So this is quite a classic demonstration of an event-driven system. So instead of services calling each other directly, you use a message broker, in this case RabbitMQ, to send message and to subscribe to messages and process those messages according to your business. So here is the flow. You can see it here. I have RabbitMQ and 4 services. Actually I have 5. So I have a catalog service, but that is only for managing the products. So this is an online store. Sorry to not mention that. So catalog, it doesn't communicate with other services. Its main purpose is to display the products. So in an online shopping cart system, the catalog is where the user view the products and they will act on the UI, such as select product and place an order. So here is the basic flow of this system. So let me walk you through this. So when an order is placed, there's an order place event published to an exchange on RabbitMQ, and other services who subscribe to this event would receive that and process the message. So inventory, upon receiving this order place event, would process that message, like reserve the stock, and if it is able to reserve the stock, then it will publish a message to RabbitMQ that saying inventory is reserved, right? So the order service subscribe to that and update the status. The payment service also subscribe to that message, listen to that message, okay, and process the payment. And when the payment is successful, then it will publish an event payment processed to RabbitMQ, and other interested services would listen to that and process the business further. So order service would update the status, like payment paid, like order paid, and then shipment, when the application secure the payment of the user, it will start the shipment, and shipment is done, then it will publish an event, order shipped event, to RabbitMQ, and it will update the order service would listen to this message, would update the state of the order to something like shipped or done, something like that. So this is the whole flow of the system. So by no means this is the standard, the correct design, but this is just a demonstration of using a message broker to communicate between services. So the services I use Spring Boot 3.4, and obviously we are using RabbitMQ, and there's another component that is Jaeger, that is a distributed tracing application that I install to help me visualize the flow of the messages in the system. So let me show you quickly how you can run the infrastructure for this. So I publish the whole code to this repository so you can have a look. But here is let me see. Wait. So this is the Docker Compose. You can use Docker Compose to quickly bring this stack up and running. So I have Jaeger here. So these are the exposed port. Actually, you only need these two. This one for the UI and this one to listen to the data from the services. The agent would send data to this port, and you have RabbitMQ here, so which is quite easy to set up. Actually, you don't need the network part. This is what I set up on my machine, but you really don't need this. So let me remove this for clarity purposes. And that's it. So you simply run Docker Compose here, this command, this Docker Compose. Here you can you need to specify the file, and you have Rabbit and Jaeger up and running, ready to use. And also let's go to the application. So we need to configure it here, and if you haven't or specified the vhost, then it would use the default / but I would recommend you to create a virtual host for RabbitMQ to separate if you use one Rabbit for many applications, which exactly I'm using. So you can create a vhost. So how to create a vhost? So let me show you. So this is after running RabbitMQ, you will have this management. So I'll go to admin, virtual host here, and you can quickly add one here. So the one I'm using is a shopping cart. So and everything, queue, exchange are inside this vhost. So that's the, I think that's cleaner. So well, let's go back to the application. So let me walk you through the services, the code of this architecture. So I have the common module here, which has some store mostly the event of the system. So this is the common module that all other services would know the data here. And also this application uses Spring Data GPA. So I have H2 configure. So if you need something like MySQL, you can easily switch to that. But H2 is quite easy to use to quickly spin up applications. I have a base repository here with common CRUD methods, so you can use other repositories can inherit from this. So now this is the catalog service. As I mentioned, it doesn't do anything other than listing the products. Then we have inventory service, which manage the inventory of the products. And the order service, this is the heart of the system. It will receive the order request and process the order, send message to RabbitMQ, and also listen messages from RabbitMQ. The payment service, when receiving the inventory service, right? When receiving the message from the order service, would reserve the stock for the order, and upon successfully reserving the stock for the order, it will publish inventories reserve, and the payment service will listen to that and process the payment. And after successfully secure the payment, it will publish a message called payment success or order paid or something. Then shipment, then because it's subscribed to the payment message, then it will go ahead and process the shipment. So that is the overview of the code, as you can go in here to explore the actual configuration. So let's look at one more important configuration before running the whole thing. So in order for these applications to send data to Jaeger, you need to first download a Java agent. Instrument OpenTelemetry. Okay, so you need to download this agent from here, from this repository. I also put this on my blog post so you can have a look, but you can go here and download the latest agent here and store it somewhere on your disk. And then if you run with IntelliJ like me, you edit the configuration here, modify the option for each service, enable this option, add VM options, then this is what you paste into. So first you attach the jar agent, give the service a name, and point to the endpoint. This is the Jaeger endpoint. So because I have a Docker host, a remote Docker host, so I need to set the endpoint here. But if you run everything on your local machine, and you can replace this IP with your local host. And that's it. That's it. What you need to do for every services. So now let's walk through the flow of the system. So I have all my services up and running here. Let me collapse this a little bit. So clear all of these things for another run. Okay. Okay. Let me bring up here. So we have, this is the catalog API. So let me get the list of the products. So you can see that I have two products here, teapot and teacup. The price be 150 respectively. So these are the products I have on my my catalog service. And then this is the inventory. So let me get the inventory. Like you see, I have quite many products here. So since these services, they are storing data in separate database, so there's no strong relationship between these services, right? So there's no foreign key, so no strict requirement that if the product doesn't exist on catalog service, it must not in inventory, so there's no guarantee here. So let me see, this is our teapot. So it has 100 items with reserved quantity to 5, so probably other order is using this already. This is reserved for other order. So let's try making an order of teapot, right? So this is the order service. So in order to make an order, then I simply post a request here. Let's see, because we have 100 items, then let's try making a 200 order. This would fail because it exceeds the actual inventory in our system. So let's try. As you can see that the status of the order is placed. So the order service, it doesn't know about the inventory. It just acknowledge that the order is placed, and it will publish an event to RabbitMQ. So other services, in this case the inventory service, would need to react to this event. So let's go to the log. So you can see that the order service, let we order, this is the create order request, this is our post request. So it will publish an order place event. And let's go to the inventory, and you see that inventory handle the place event with quantity 200, and obviously it doesn't have enough stock, so it will publish an inventory out of stock event. And if you look at the payment, there's nothing here because we stop the flow because we don't have enough stock. And also there's nothing in the shipment. And order service here, we see that it receive out of stock, inventory out of stock, and then update the order to fail. So that is the failed event. Let's try with something smaller, like how about order just 2 items to ensure that we have enough stock. So let's execute this order and check the log. Okay, so this is the inventory service. So inventory service, let's go to the order. Okay, order fail, right? But at the start, like where do we have the quantities? 2, order service, order placed. Then we go to inventory handle order placed, then order reserve, and the payment, right? And payment fail because we simulate a 60% success rate here. So when payment fail, there's no shipment as we expected. Now let's try this again because we have 60% chance of payment success. Hopefully this will go through now. So I skip again, and we have the shipment. That means payment was successful. Okay, payment success. Then we have the full flow. So let's see the full flow in Jaeger. So let's go to the home page here, file traces, and the most recent one is this one. So this one, the one with success payment, and this one with only 46 spans. This where the payment failed. So you see that in this successful flow we have 63 spans, and we have shipment service, and in this one we don't have the shipment service. And if we click here, we see that we have the full picture of the flow of the business, the message. So this is the benefit of having something like Jaeger installed to your system, so you can see where, so for example, you see that your flow take like 10 minutes to complete, then you can look here and see which service, which execution take the most time, and you can address those issues quite effectively. So that's it for the demonstration. So I also put this in a blog post if you prefer that format. So I will put everything on description. Also, the whole code of this video is up on GitHub. So I will also put it in the description of the video. So thank you very much for watching, and I'll see you in the next video. Thank you. Bye bye.